Hi, everyone. Good morning once again. I think most of you maybe already have seen me today. Sorry about that. Yeah, and maybe I'm familiar for the rest of you as well because my team and myself, we won the Best Paper Award last year, as well as the Best Contribution to the Sustainability Tech Track. Alongside with me this year is our founder and CTO here in the first row, Struckmeier. He will be also available later for some questions or networking sessions if you like. So today we will present a sequel to the paper, which is titled From Water Consumer to Water Producer, Modular Ultra-High Dense Direct Hot Liquid Cooled Sustainable Data Centers. And let me also mention here that this, again, is a group effort, so there are other co-authors also to be mentioned, such as Andreas Hansch, Konrad Richter, Anne Weisemann, and Jaime Comella. So before we start, just a quick 101 on who we are, what we're doing, what we're about, why we did win this award last year. Sorry again, this might be a recap for those who already were at my first session today. So just very briefly, we developed a very disruptive concept, which we call energy to data, data to X, and X being heat, cooling, or water. So roughly 11 years ago, our founder realized that data centers emit massive amounts of heat. So it's an energy gift, let's call it like that, which is there by default anyway. So why not use it? So the first step in order to use it, of course, the idea is how to capture this waste heat. So we are capturing the waste heat with deionized water. So in a liquid, direct hot liquid cooling technology, we call it. And that way we can capture up to 90% of this emitted heat. Yeah, so the first idea, of course, was directly use it for heating, of course. So what we did, we used it to heat spaces such as office spaces, residential areas, and even greenhouses. And then a couple of years later, we realized, what about the rest of 2/3 of the world where there is no such thing as real heat demand, right? There's still computational workload, but they have other energy pains, such as AC and cooling needs, as well as freshwater production. So what we did is that we said, OK, let's just use the waste heat and coupling it with an absorption chiller, and that way we can turn the heat into cooling. And like the heating process, we just cool the spaces, the offices, the residential areas, and even greenhouses. I forgot to mention that I'm a German, but I live in Dubai. So where I'm from, we have to cool greenhouses for 80% of the year. And that can be done more sustainably, without doubt. And the third pillar is freshwater production. So again, in Dubai, every drop of water we consume is artificially made. So it's either done by desalination of seawater, or there is some groundwater which needs to be sourced. So what we're doing is we're using the waste heat via this direct liquid cooling technology in the data center. And we have a MED desalination plant close by. We are coupling them together, and the whole desalination process is run by the waste heat. And that way we can produce potable drinking water, CO2-free, and almost without additional costs. Yeah, that's pretty cool. And that's why we had this buzz, and during the OCP, we won the award. And honestly, just at this point in time, I want to thank OCP and the FTS Symposium for the great exposure and the awesome sessions afterwards. There was so positive feedback. Thanks again, it was a great time. So again, in this last paper, we aim to show everyone the potential of direct to liquid cooling, right? So we talked about what concepts are there in terms of waste heat, and that's sustainable, yes, it's energy efficient second, but of course, it's also a business model. That was what we were doing. And we had a call to action where we said, OK, please, chip and server vendors, optimize your systems for liquid cooled high temperature. So let's see, status update 1 year later, what really happened.
Yeah. So we're very thankful that we can contribute to the Open Compute Society, and even more thankful that we heard yesterday that sustainability is one of the big pillars. That was 12 years ago when I founded the company. My main motivation that I have 2 children, 2 girls, they grow up, and I think we need to do more to sustain the world, right? And we cannot continue as we do continue on. And this is a big chance that digitalization will change the world, but also that we can find a way to do this, the digitalization in a very sustainable way. So every kilowatt that goes into a server electricity-wise is every kilowatt is 1 kilowatt of heat, right? So typically waste, and you take an air conditioner to get rid of it. So to make use out of this heat, we have the following problem. Heat is not equal heat because you have also the exergy. So that means at which temperature level you have the heat. And that's important. Normally you get warm air out of a data center, and that's not very useful, considered as waste heat. Yeah? As soon as you raise the temperature level, so have a higher exergy, it becomes more value. And to achieve this is a huge effort everybody has to kind of work on to make this heat usable. And I think the OCP is a great opportunity also to talk to manufacturers, vendors, especially also to manufacturers of the semiconductor devices, to design their devices not only for maximum performance and high efficiency, but also to the level of excess temperature you can get out of this device. And I only name 3 here, but there are many more manufacturers, right? But these are the 3 we have some intensive discussion about this temperature question. And we want to get hot water out of the water circuit loop that's cooling the devices. So with Intel systems, we're achieving right now 65 degrees Celsius. This is pretty hot water. Everything above 60 is very usable for residential heating or for heat recovery purposes. And we're talking to the manufacturers of servers like Dell, Lenovo. Their liquid-cooled systems right now about 55 degrees Celsius, and we try to push the limit to go higher, right? And from the physics point of view, it's possible. Even in the design process of the processors, you have effects like electron mobility or junction drain, and you can optimize by designing your chip what kind of temperature level this chip is running at its optimum performance. And we know from other semiconductor companies that they can design chips that operate at 90 degrees or even 110 degrees Celsius, or even above in, for example, aerospace applications. They have those chips. So there's not a physical barrier that prevents you from designing chips to go to higher temperature. And the higher you go, the more you can do with this heat and the more of a value this heat has. And we're actually selling the heat all in some of our data centers to customers, and then I pass it along to Leonie to finish the talk. Thank you very much.
So to sum up, that's already quite good, but there's still room for improvement, right? So it's not great, but it's good. So we all know that traditional air-cooled data centers are, besides being electricity guzzlers, they're also big water guzzlers. So in the US alone, they are one of the 10 worst water guzzlers, specifically. And estimates are that 7.1 cubic meter of water per megawatt hour of energy consumption is needed for a traditional air-cooled data center. But traditionally, I always get the following feedback. Leonie, that's how it is, that's how it has been, and it's how it will be, right? Wrong. Today, I want to show you how we can turn a water consumer into a water producer. So we designed, built, and tested such a modular, ultra-high dense, direct liquid-cooled, sustainable data center, making its waste heat usable. So with this 2.16 megawatt server capacity fitting into a 14 feet high cube container, it has space for up to 12 racks with 42U and a hybrid cooling system, electrical installations necessary to run the IT equipment, and network installations and safety measures. So this setup translates into nearly 100% of the capture in the data center and supply approximately 60 degrees at any suitable heat consumer. So we have done some experiments, and I want to show you some key takeaways for today. So first of all, the PPUE value. We achieve in this setup 1.017 plus minus 0.003 PPUE value, which is pretty great. Secondly, the IT load of approximately 1,500 kilowatt at a temperature gain of 15 Kelvin over the servers. And most importantly, no water consumed. So that's pretty great already, but it doesn't stop here. So remember what I said, we have this whole thing, we started it, this being very energy efficient, solely because we want to capture the waste heat. So if we now think about desalination and the whole topic of driving a desalination plant, we even calculated that we will produce up to 251 liter bottles of water per minute with this setup. And that's how you turn a water consumer into a water producer. But this doesn't stop here. So as you remember, with our very disruptive concept, it's not just that we can produce water. We can also, for example, produce cooling. So with this setup, we can cool up to 300 office spaces in very hot regions, such as Dubai, or heat up spaces up to 32,000 offices in Germany. And only considering the cooling needs of the data center and not the positive effects of waste heat recovery, we can save as much as 1.9 million carbon dioxide emissions, which will be absorbed by 1.9 million trees, sorry about that. So it's an equal space of 6 times the area of New York City's Central Park. So approaches like this will enable us, the data center industry, to be more sustainable and energy efficient, and it will equip us for the new computational tasks, which will be HPC, AI, and emerging technologies such as brain-like computing. So we can transform data centers really much from being resource consumers to resource producers with this circular economy setup. So this will be a very flexible, scalable, all-terrain modular data center setup. And this way, we can bring computational power almost anywhere and transforming the waste heat into an asset. This will have very much positive externalities and will ease conflicts about some very critical topics such as food, water, and intact ecosystems. Thank you for your time.
Thank you, Leonie. Do we have any questions for her? Yep.
Thanks for presentation. One question: do you plan to make that modular data center OCP open source? I mean, do you work with modular data center group?
Yes, so the design of that modular data center is as it's called, modular, right? So it's modular. So we have a 19-inch version, which is kind of more the traditional, but also a 21-inch version with some of the OCP concept, and we're also working on the liquid cooling track to get the design of the liquid cooling track into that, and we're contributing our knowledge into the OCP concept as well. I think all the knowledge people learn about liquid cooling and so on, we have to share because it's a very complex topic. It has been around for a couple of years, but there are many things you can do wrong, and people have also done some bad experience with not having enough knowledge how to do it. So I think it's very important to share that, and we'll do our best to share this information and to educate people how to do it and be part indeed, and we're happy to be part of the OCP team.
And adding to that, one of the co-authors, maybe he's sitting here somewhere, Jaime Comella, here, he is also co-chair of the cooling environment work stream. So we are very much actively contributing, and feel free to also reach out to Jaime. He will also have another talk later today at 4 p.m.
A panel discussion, I think, this afternoon. Yeah. Mm-hmm.
Great, thank you both.
Thanks.
Thank you very much.